Hey guys, how's it going? I'm back here with another video, and I would like to welcome you guys to probably the last episode of this series where I teach you guys GraphQL from the beginning. And the reason why I want to end this series is because I tried brainstorming a lot of different topics that I would add and demonstrate throughout the next episodes. However, every single topic that I ran into was either too complicated in the sense that if I put it in a beginner series, it wouldn't make sense. It would make a lot more sense for me to put it into a intermediate GraphQL or advanced GraphQL series that I might make in the future, or the topics weren't valuable enough or weren't like it didn't have a very common use case, so it would make sense again to add it to this series where I honestly am trying to get you guys to focus on the most important stuff and just trying to make you guys feel comfortable with GraphQL. So I decided that this is the last three topics that I want to go over, and I will go over them in this video. So right now we're going to go over three different things. We're gonna first go over what the different arguments that you can use in a resolver function, so the different inputs that a resolver function might get. We've talked about the args input, but there's three more that I haven't went over and I think are important to at least understand. I also want to talk a little bit about fragments and a little bit about error handling and how to use unions to different methods of making cleaner code in GraphQL and how to error handle in a way that is acceptable in the industry. So with that in mind, let's get into the video. Okay, so as you can see over here, we have this query which we've been working throughout our series. You can see that in our, I'm gonna zoom in so you guys can see it a lot better. But in our type definition for our query, we have a query for all users and a query for all the movies. And what I'm doing right now is I'm just making a simple query and I'm accessing and asking for both the list of users and the list of movies, which is something that I can do at the same time. And you should see that the result when I run this is a list with users and also a list with movies. This is something that I didn't show in the previous videos, but you can do it as well. But the reason why I'm using this is because I want to show you guys an example of the different things that we can write in our resolver inputs. So if you recall, each resolver is a function, as you can see over here. And we've been previously, whenever we want to ask for the client or whoever is making the request to send some data, for example, if you're creating a user, you want the client to send the data for the user, right? Or if you're requesting information about a user, you want the client to send an ID. So to access that information, we can access the second argument in this function called args. And I've previously told you guys that to access the second one, there's a first one which is called parent, but it really didn't go over and we really didn't use it. So I will talk about that one right now. And one important thing is, it's not only parent and args, there's actually four. So the third one that you might want to access is called context, like this, and the fourth one is called info. And all of them have a different purpose. Some are more useful than others, but the important thing to understand is that even though some of them, like info, is rarely used, especially in the beginning, you need to understand its use cases so that if you find yourself in a situation where you might need to use it or might need to access the information about the request, you might use this kind of different aspects of GraphQL. So the first one that I want to go over is parent. So what exactly is parent? So when you access the parent input in a resolver function, it will basically return whatever was returned from the previous level in the GraphQL graph. So I know that sounds weird, but if we really think about it, let me make a comment over here just to show you guys something. So we have this graph over here, right? This is just a comment. We have over here the highest level, which is the query, right? And below this level, inside of the query, we have, let me go to my type definitions. We have users, we have movies, right? And we have all this stuff as well, but let's focus on the users and movies. So for the users, let me just put an arrow over here. We have users, which is a level below the query level. And if we go to the type of user, which is what it returns, there's actually another level, because not only does user return from users, but it also returns a movie for the favorite movies. And that's why we do have a resolver individually for user where we say what favorite movie is, right? So we have this resolver. I explained this, I think it was in the 4th or 5th episode, but we have 3 levels in our user's query. So we have favorite movies over here. Now what happens is when we make a query, the parent over here will be undefined because query doesn't, like this level doesn't return anything. But when we query users, this over here will return whatever we want. So for example, over here, when we're querying users, right? So in our case, it is returning a list of IDs and names. So it's a list with a bunch of objects for each user, which includes the ID and name. So the value that the level of users is returning is this list of user IDs and user names. Now, then we have this over here, which returns a list of the favorite movies, right? This is what we made it happen over here. So the problem is, over here, the parent will be undefined because query doesn't return anything, but in the favorite movies resolver, the parent will be whatever users return. So you're just accessing what the previous level returned. Now, if we had another level over here, another level, so another level would mean, for example, inside of movie, there's some field that returns another type. So that if we had that, then basically we would have to another level will have a parent equal to whatever favorite movies return. Now I know it sounds confusing, but let me just show you. So if we have this users over here, and I access the parent, which is the first argument in the first input in the function resolver function, and I console log this, let's see what happened. I'll open my console log over here, my terminal. You should see everything is working perfectly. If I run this query, it should execute the users resolver because we are querying for users, and that means that it is console logging the parent, and you can see it is undefined. Now, if I didn't do it in the users level and I did it in the level below it, which is the favorite movies resolver, and I access the parent, you should see that if I console log this, like this, parent, you should see that if I open my terminal over here and I run it again, what it should console log is all of this over here because it is the return value of the previous level. And you should see that, did it work? Did we actually save it? Oh, we did, like it's working perfectly, but I forgot something. This won't be executed unless we actually specify in the user's query that we actually want the favorite movies field. So let's just say that we want the favorite movies field, we want to see its ID and its name. So the ID and the name for each movie that is a favorite movie for this user. So now if we open up a terminal, you should see there's nothing, but if we execute the query, you should see that it returns perfectly. It returns the information about the user that was console logged. Now, one thing that you might have realized is that, well, it isn't exactly what we returned. And the reason for that is because over here, we're returning the ID and the name. Those are the only fields that we asked from the users. But when we access the parent, it returns much more than that. It returns every single field that a user can have. So this is an important aspect of it, and it includes friends, it includes nationalities, it includes age, which we didn't specify in our request. And this can be used for many things. The use cases in our case aren't very valid, but you should see yourself using this a couple of times, especially in a large project. So I think it's important for you to understand at least why it's useful and how it works. So now that we went over the parent argument, we've went over args, we've used it so many times. Let's go over context. So what exactly is context in GraphQL? Well, context, in my opinion, is the second most useful input that you can have in a GraphQL resolver. And the reason for that is because context is useful for many situations, including authentication, authorization. Also, if you're using some sort of library that, or some sort of API that will communicate with your resolvers, and you need to have that quick access to different variables and functions and classes inside of the resolvers. And you'll understand why. basically context allows you to pass variables, numbers, whatever values throughout every single resolver. So if we have a value or a variable that is useful throughout every single resolver, for example, some sort of authentication method or some sort of token, we can pass it through the context, and every different resolver function will have access to that value by accessing the context. Let me give you an example. To create and pass information through the context variable, we need to come to our index.js, and where we declare our instance of our Apollo server over here, we need to add a context property over here. And context is a function like this that returns an object. So in our case, I'm going to open this up a bit so you guys can see it better. At the end, we need to return an object, and it can be whatever we want. Just as an example, let's imagine that we want to have access to an object with a property called, or key called name, with a value called Pedro. So we have a user who has been logged in throughout the application, and their name is Pedro, right? And we want to have access to that name throughout every resolver. We can pass this as the return statement for our context. And if we come to any different resolver, for example, let's do it for the user's resolver, and we come over here and we write all the previous inputs until we get to context, and we console log the context. Let's see what is console logged. So console log context. Let's open our terminal up. You should see nothing is console logged, but when I execute a query that queries users, it should console log whatever we returned in our context object over here. So you can already start seeing why this might be something important, because we can use this for many situations, including and most importantly, authorization and authentication. Another example of why this might be useful is, imagine if you're using an ORM for a database system, right? So many people use MongoDB. So if you have a MongoDB model that you want to have access in every resolver, you can pass them over here, like user model, and I don't know, just access it throughout the resolvers without having to import them in every single file. You just access them in the context, right? And that's cool. That prevents unorganized code, and it's useful in various different situations. Now, one thing that I wanted to point out is a lot of people get confused in regards to like things that can be done in normal Express, in normal REST APIs, and how to do them in GraphQL. One of the things is accessing the request information, like the rec object that every request has in Express. So you can actually do this with GraphQL by passing this rec variable inside of the context. So to access a request object for every request, you can just pass it as the argument to the context function by grabbing it like over here, and you can pass it inside of here. You can say rec, and you're returning the request. Now, if I come to my resolver and I console log my context again, like I've been doing, you should see that when I run this, it should console log information about the request, and it includes everything, right? It includes the GraphQL like query, what we wrote, the type of method, the status code, if it worked, if it didn't work, even like the information about the computer you're using, right? So it's really interesting because a lot of people are confused by this, and this is how you can do something like that. This would be very useful, for example, if we were passing headers to our GraphQL API for some sort of authentication authorization method. If we said context.rec.headers, for example, in our case, we're not passing any headers in the front end, but this is how we would access, because if I execute this query, it should say the headers for the request, which in our case is this, but we didn't pass anything like specific, and we didn't pass any tokens, anything like that. But I just wanted to show you guys exactly how you would do something like that. Now, this is context, and it's really useful. It's more useful than parent, in my opinion, and than info, which is the next one we're going to look at. So keep in mind and understand it fully. You can play around with it and do different examples just so you can get a better grasp of exactly what you can do with it. Now, let's talk about the last input you can grab from a resolver function in GraphQL. And I won't spend a lot of time on this one because, to be honest, I don't think I've ever used it in a actual situation. This argument is the info input that you can get. And I'll just console log it so you guys can see what it is. If we console log the info and we execute the query, you should see that this is what it console logged. It's just some information about the GraphQL request. It's not exactly like a rec, like we just console logged, because it doesn't include a bunch of methods and stuff related to the request individually. It is very like funneled towards the GraphQL aspect of the request. So for example, it gives you the field name, which is users. It gives you like what exactly it is. It is a query. It kind of gives you the schema as well, some validation errors if you had any extensions, any descriptions you put. It specifies exactly how the type is. So specifies everything from our schema over here. And it is interesting just to take a look at it. I don't find many use cases for it. In the beginner level, especially, it's somewhat useful, and when you're doing some more advanced stuff. But for now, let's just keep it like this. You won't be using this a lot. I just had to go over it because I didn't want you guys to not at least like have an idea of what it is. So this was info, and this were the 4 different inputs you can grab in a resolver function. Feel free to use them whenever you want. They are important and they will be useful in different use cases. So just knowing how they work and what they're used for is important, so that if you find yourself wanting to use one of them to solve some sort of problem, you can at least know that they are part of the problem solving, the solution, right? So now that we went over this, let's go over another important topic in GraphQL that I wanted to talk today, which is fragments. So what exactly is a fragment, right? It's kind of weird to explain, and the use cases might not be as useful in the beginning, but I would say that fragments are mostly used for like organization purposes, for maybe reusing code in the client, so that you don't have to keep copy and pasting the same code 1,000 times, right? And what happens is in the client you can actually impose limits to fields that you're querying in a query. So what do I mean by that is, imagine that we want to query our list of users, right? So I want to delete this over here, and I want to query our list of users. But imagine all I want to see from these users, for some reason, I'm in a page of my website where all I need to see is the name and the age, right? I need to specify that, and whenever I use this query again, I don't want to have to put down these fields again. Now, it's only 2 fields, but imagine that users may have a lot of different fields. Like many websites have some important type, like users include a lot of stuff, because a user in a website can include many different fields. And you don't want to keep having to write all the fields again. What you can do is you can kind of specify what these fields are inside of a fragment. And it's almost like, the analogy I like to make is almost like setting the fields equal to some sort of variable and reusing the variable, so that you don't have to list out the fields that you want from this type ever again. And it also imposes a limit, because you can't add stuff to the fragment after it's created. You can query other fields on top of the fragment, but that doesn't matter that much in our case. Let's just get into how do we create the fragment. So what we do is we just write inside of our client, not in the backend. We specify, I want to get a fragment, I want to give it a name. So let's call it get age and name. It's a horrible name for a fragment, but let's just call it like that. And we need to specify which type is this fragment going to be based on. So this fragment will represent fields from the type user. So we can say this, we open and close curly braces, and then we specify which fields we want to get to query from user, which in our case is name and age, right? So let's just put both of them over here. And what we need to do now is, when we make some sort of query that uses these fields, this specific fields, what we can do is we can just say ... and then specify the name of the fragment, which is get age and name. And you should see that when I run this, it will query only the age and the name. And if I add more to this, like the nationality, it will automatically understand, and you will query all of this. Now again, this is mainly used for reusability, and it's really cool. I like to honestly use it. I use it sometimes for specific types like user, because it usually includes a lot of stuff. So feel free to use them how many times you want. They are created in the front end, so you got to keep that in mind. And yeah, that's basically what fragments are. So it's a pretty small topic. Now I want to really talk about some more type of advices that I would give to someone working with GraphQL on how to make their code look better for industry standards. In the sense that, like, how do you error handle specifically? How would I error handle in GraphQL? It's something that I learned in a previous job that I had, and I feel like it's very useful, and it is one of the best ways to error handle, because it provides you with a lot of insight on how to work with GraphQL and how to think of GraphQL as graphs, which is one of the main points of GraphQL. So what I'm talking about is error handling by using unions and result boxes. And what I mean by result boxes is basically whenever we have a mutation or a query, we want for its return type. For example, let's go to our query over here. This query over here returns a list of users, right? But the problem is, what if there's an error? And what if there's a specific error in our API or in our database that we're not seeing over here? Well, GraphQL specifies primarily errors related to GraphQL. So, like, for example, you put instead of an ID when you make this query, you put a string or a boolean. GraphQL will recognize that and will return an error. But what if there's an error making a request to our database, or there's an error making a request to an external API? Well, GraphQL won't really give that much information about it, so we need to do that ourselves. But how would we error handle in this case? Well, what I like to do, and what I learned is one of the good standards in the industry, is you can basically create a union between this return type, which is what we want, so the successful return type, and the error. Now, how would we create this union, and how would we actually make it work so that we are returning either one of those things, right? So basically what we want to say over here is, for this users type, or this users field, we don't want to return this. We actually want to return a union of two different things. One thing will be this result over here, and the other thing will be some sort of error if it occurs, right? So what we do is, we can create over here at the bottom a union and call it something like users result. Now, to create a union, you just write the union keyword, and you write the name of the union. Then you set it equal to two different types in GraphQL. Now, it must be types. It can be scalars. It can be arrays or whatever. It needs to be a type. So this is kind of a problem for us, because the successful return type for our user is an array of users, right? And the problem with that is that we need to make another type which includes this as one of the fields. So this is how we would go around this. I would come over here and I would create a type over here called users successful result. I know the name is horrible, but just bear with me. This is the type, and inside of it, it has the type users, and it returns this over here, which is what we want to return from this. So we put it inside of here, and we say that this is the successful result from querying a list of users. Now, this can now be used as one of the options in the union, right? It can either be this or some sort of error object, some sort of error like that is returned from our API. Now, for that to happen, we also need to create the error type. So I'm gonna call this users error result, and it's a type, and inside of it we can put how many things we want, but let me just put a message which represents the error message from this request, right, or from this query. So the type of message will be string, and I'll make it required as well if it eventually happens. So now we can say that this user's result is a union between the user's successful result and the user's error result. So the way we make a union in GraphQL is we keep separating the different results that we can have by putting this vertical line over here. Now we have these two types merged together that can be both representing the result from our user's query. So now instead of just coming over here and saying that users return users, we're now error handling because we say that users can return users result, which can either be an error or the array of users. Now, how do we handle this? Because it is important to understand that right now we're not doing anything related to the user's error results. It just exists, but we're not actually, like, if there's any error, what exactly do we do? Well, the way we do this is by basically we're going to come to our resolvers over here, and you recognize that we created a new type called users result. So what we have to do is we need to actually create a new resolver field for the user's result. So I'm going to come here down at the bottom, and let's just create a new like on top of the mutations type and on top of the users type, there's another type which is on the highest level, which is called the users results type. So users result, like this. And this over here will include, in our case, only one resolver, and that resolver will resolve for both cases, for the success and for the error. So remember what we had over here, this this resolver over here for users. It's kind of not as useful right now because we don't have, like, the return type is not this. It is actually a union between two different things. So we need to focus on this resolver down here at the bottom, which will resolve and we'll check to see if there was any errors or if there wasn't any errors. And the way we do this with unions is actually, it's a bit different. A resolver and for a union uses something called a resolve type, which is basically like a different type of function which you can use from Apollo, which allows you to specify what is being returned and like which of the two options from the union are actually being returned. So from it, we can access something called an object, which will allow us to see the fields that are returned from our original resolver over here. So what we're going to check inside of this resolver is the following. We're going to check if user list is equal, it exists, then we want to return the user list, right? So basically, it's almost like if user list was like our database. So we were querying from a database. If there's no errors, if it actually returns the list of users, which is what we want, then return this. But if it doesn't, then it will come down here at the bottom, and we'll get to a point where this wasn't true, so it should return an error. So what we're going to return is an object containing, let's think about it. It should contain a message, and the message will be, yo, there was an error. And by the way, this over here is wrong right now because if you recall, we changed the type for our union. Our union doesn't return just a list of users. It returns a type called user successful result, which is an object containing a users field, which then returns a list. So instead of just returning users list, we need to return an object containing a field called users, which is equal to user list. And if this is confusing, which I know for a fact it might be, I just need to tell you guys to relax. This is a complicated topic. I definitely didn't get it first time. I'm just pointing this out so that if you need to reference in the future, watch it a couple times, practice on your own so that you can actually understand everything. And don't worry if it seems confusing in the beginning. But basically, we're returning now either this, which is the first option, or the error, which is the second option. And we need to know if which one of them were returned inside of our user's result resolver. So the way we know which one was returned is over here. We can come and say that basically, if the object that is returned has a field called users, then we know for a fact that it is a user, right? It was correctly returned. So like it was successful. So we can just return the actual object.users that we received. We're just saying, okay, if there was no errors, return whatever we received from our resolver above. And if the if it doesn't have that, then we just know it was an error. So what we want to return is we want to return the object dot error. So object dot message, right? The object dot message. So these are the two things we want, and the way we specified this and the way we tried this is let's open this up over here. We have our API running. Let's try querying for the users again. I'll just specify that I want the ID, the name, and the age, right? It's giving us some errors, and the reason why it's giving us some errors is because we changed the return value of users. And this is something extremely important. You can see that the return type for users now is users result. So how do we specify in the front end what we want from querying a union? Well, the thing is, when you query a union, there's two different options, right? There's two different things that can happen. A user successful result or a user's error result. So what we do is we need to specify what we would want, like each field that we would want, depending on which case is returned. So in the case that it returns a success, we can put 3 dots and say on user result, not user error, but user successful result. So if there's a success, then we want to grab the ID. We're going to grab the, actually it's not, then we want to grab the users field, which is inside of this, and the users, we want to grab the ID, the name, and the age. I know this is confusing, but basically what we're saying is if the result was successful, then we want to query the users from the result, and for each user we want to grab the ID, the age, and the name. Now, if it wasn't successful, and if it is the case that it actually returns a user error result, by the way, it can only return one of those two types, or else GraphQL will just give an error saying that it returned a wrong type, right? And if this is the case, then what we do is we basically say that we want to grab the message, and this is it because message is a string, is a scalar type. It's not an object like users. So we can just grab the message individually. So now this is how we would form it. And if we added more stuff to our union, we could add more of this over here. So when we run this example query, you should see that it must resolve to an object. It gave us an error, and this is the message that we received. Now, the reason why we received this message is because of the following. I actually made a mistake here. The return for when you're resolving a union is not exactly the result that you want to return back. You need to specify which of the options occurred, right? So, for example, we called in our union resolver over here. It can either be of type user successful result or user's error result. So what we return in our union is, for example, if the object.users exist, then we know that it was the user successful result because users doesn't exist in the other type. The other type only includes the message field, so we know it was an error if the message field exists. So what we do is we actually return a string containing the name of the union type that occurred. So in our case, if it was successful, the option out of the union was the user successful result. So that's what we return over here. Then we do the exact same thing, but for the message. So we just put if object.message. Then we know it was an error, and we just copy the user's error result over here and paste it down the bottom. Now what happens is, if none of those are true, then it was a GraphQL validation error or any sort of GraphQL error that occurred. So we can just return null in this case because it will know that it was a GraphQL error instead of an error that we predetermined based on some sort of API call or some sort of database call, something like that, right? So when we have this done, we can just come over here, open this up as well, and try to run this, and you should see that we get back our data. We get back data, users, a list of users perfectly, because what we did is we said that if the list of users exist, then return a successful result, right? But if it doesn't, then return an error. So let's see the case in which it doesn't. So the analogy we would make here is if there was an API error. So we made an API request for the user list, but we didn't get that data. What would happen is the following. I'm going to come over here to where we define our data, which is over here. It's in the fake data.js, and I'm just going to delete this over here. I'm actually going to set this equal to null. like this, just for a second, so we can see what would happen. So users list shouldn't be existing. So when we run this query, you should see that we get back an error type. It says abstract type users result, and it gave us an error message, but it isn't the error message that we wanted. It says abstract type user result was resolve a type users errors results. Oh, okay. I think I put it. Yeah, I put an s at the end over here when it shouldn't be. As you can see inside of our type definitions, it doesn't have an s at the end. So when we run this again, you should see that it recognizes there was an error that we determined. So it gives back a message saying, yo, there was an error. But if we go back to our fake data and we put back the data, you should see that it actually returns the data instead of the customized error message that we created. So this is basically it. I know it's a lot to unpack, but feel free to rewatch it a couple times. Feel free to ask any questions down below, because I'll be taking a look at them. I really hope you guys enjoyed this. This is also the end of the series, and I really loved this series, honestly. Although it definitely was one of my worst performing series ever. I feel like just explaining topics that are interesting to me and topics that are a little bit more advanced are interesting, and makes me happy when I record those videos. And for that reason, I'm really happy that I was able to make this series. I'm really happy for everyone who left the support in the comments. So yeah, that's basically it. I'm also gonna post this series as a whole video, a full video of like 2 hours long. I don't know how long it's gonna be, just because I know that some people prefer it that way. And if you're watching that video, thank you for watching as well. So yeah, that's basically it. All the code for everything will be in the description, as it always is. So I really hope you guys enjoyed it. If you enjoyed it, please leave a like down below and comment what you want to see next. Subscribe, because I'm posting 2 times a week, and I would massively appreciate it. And yeah, that's basically it. Really hope you guys enjoyed it, and I see you guys next time.